I want to go to Mark Sokol. Let me ask you to unmute.
Hey,
There we go.
We got our safety glasses on.
Good.
And this is a great segue into the next device, which we finally got running after months of R&D. This is basically it's like a gyroscopic spinning device where it's going to swing forward slowly and then swing back fast. So it's pretty similar to what you're doing, except that instead of the rotation of the gyroscopes are laminar, they're rotating at the same speed. These are being swung outward and backward at different speeds. And we have servos on either end that are working together to make this happen. Tom over here, Tom Butler, helped us out with the both the machining of the parts. We set it up on the CNC machine, and also programming the Pololo, which was quite an ordeal. Here, you want to power it up?
Absolutely. Here it is. Let's do it.
Flip those switches. There's a timing set into it.
Little delay.
A little delay to make sure that everything.
So you're prepared.
I'll flip the camera over.
Turn sideways. Sure. Really got to hold this sucker in place.
Here, pull it with your glove. Oh. Okay, yeah, some screws started popping off, so it looks like it's time for Loctite.
Yeah, yeah. What happens when you rev it up?
Oh my God. Yeah, that came loose. Okay, so it's time for some Loctite on that unit. It's been a while since we last had a presentation here at APEC, giving you the latest updates. We've ran a couple more experiments on the Alzofon EPR experiment, but I'm going to do an update on that on another day. Probably compile all the videos together and give it to you all at once. We also have a couple more experiments going on later in the week that I can't talk about yet until they happen. And that's pretty much it for now. Plan on putting this on on some sort of platform with ping pong balls underneath it for ultra low resistance, measurements to see where it's moving. But right now you saw it was starting to fall apart from all the vibration. So we're gonna have to probably put some Loctite on those things. Do we have Loctite? I think we might have it in the epoxy box. Hey Ross, are you still there?
Yep.
What do you think of that?
I mean, it's cool. I mean, it's doing what you wanted to do, but I kind of like the whole idea where you said the whole swimmer's like arm movement where you're gonna do your you know, like you're gonna reach out and then turn like that, and then
Yeah, that's what I was doing. I mean, the amount that it goes forward is just an issue of software. It can do a full 180 if you want it to.
Yeah.
So that's all programmable stuff in the software, but the hardware is there to do whatever you want it to do. And you just gotta put the numbers in the computer and tell it to do that.
This amount of movement was recommended by Mike Gamble, who's been helping us out with the construction.
And not to don't forget to mention the people at Palolo who are
That's
helping out
right,
with
they
the software.
did, very helpful. Dr. Tom Balone, he was helping out.
yeah. So it's sort of like you're trying to like interact with the actual pole itself, right? Which I mean, it's possible. Maybe I'm not sure. I mean, like I was saying in my presentation, I like to actually interact with the 2-point masses on a gyroscope physically itself, instead of trying to kind of like, I wonder how I can mess around with the pole and kind of play around with the pole there. But maybe, I mean, you know, maybe it's possible. I don't know.
Another thing to mention, I don't know if you noticed this, but when we had that emergency, we had to stop the gyro spinning. He used his sweatshirt, yeah, to rub up against it and kill the momentum. So that's a useful thing to have. Like if you ever have an emergency, you need to shut the thing down. Just some cotton cloth. It's an amazing way to kill a gyro's momentum, turn it into heat. I'm wearing short sleeve shirt and that's not good. But like if you have a shop rag or something like that, Eric Lathwaite had a special carpet next to his experiment spot where that they would use to kill the gyroscopes. Okay, that's good. Yeah, lots of vibration going on here. Okay, Tim, I think we're done with that.
Good deal. Well, that was fast, man. Okay, so I guess now let's go to open discussion. So with open discussion, let me see, and everybody can unmute themselves. Oh, you know what? We have let me see. You know, I have a couple of questions. Mark, I have questions for you for the lab.
Oh, sure, go ahead.
Okay, let's go to Robert first. We'll come back to open discussion. We have a presentation. Phil Bouchard has someone who's going to present today. But let's go to Robert first, sir.
Well, Tim, I was going to ask some from Ross. So go ahead with your questions first if you want. But I'll go ahead and ask. Ross?
Yep.
Hi. Do you have your machine in front of you with you?
Yeah, one sec.
Thanks. Hypothetically, you were talking about hanging it in a warehouse by a number of metal ropes.
Yes.
In what direction with the machine are you hoping you think the machine would move to stay there at a, I don't know, what would you say, 20, 30, 40 degree angle?
Well, right now, like the idea is it's trying to crew up right now. So
Oh, I see. So it has to be outside.
yeah, I would have to turn it on its side and
I
then
see.
and then put like at least four braided stainless steel wires all the way up to the ceiling. So there's a lot of physical play, and then turn it on.
Okay.
And then I mean, it would have to like deviate by like I said, 20 feet and be all the way out at like a crazy 45-degree angle, or there's no way that the regular physicist would agree that this is, you know, like they're always going to come up with some type of like, oh, that's not actually working. And
Yeah, explain it off the map. Yeah.
Yeah, most physicists, I'm telling you, that's why I haven't had my door knocked on by the DOD yet, because if they do see this, they're going to be like, oh, that's not going to work. That idiot, he's an idiot. He's stupid. They like Robert Cook tried that. Dean tried that. Eric Lathwaite tried that. Thornton tried that. All those idiots. Ha ha ha. Those idiots. And ha ha. And I'm going to be laughing at them in the end when it actually works. And then,
Well, Ross, it's the stupid people that get things, discover things that's not discovered by regular engineers and scientists in the mainstream. They're the ones who get the things going. I take it, do you have a degree or don't? Are you strictly machinist?
I actually have a master's of public administration from George Mason.
But in science and engineering?
Not in engineering or science or anything like
Okay.
that. So.
I always, in my experience, always the machinists are the real designers. The engineers just make drawings for them.
Yeah, the guy who thought up this whole theory, Mike Marsden, or Michael John Marsden, he made up what's called the MAC-1, MAC, which stands for macroscopic. Quan stands for quantum. So it's a macroscopic version of the inner quantum workings of matter. That's what he says. Not this machine, but his machine, which I don't want to show you all. I don't want to give away his invention.
No.
His invention, like mine has these springs that kind of go ding ding ding. His is like it's way more efficient. There's no crazy. The linear tethers are like this. I mean, it's like it's really awesome. His machine. Really? He says it. I mean, I haven't been there to see it, but he says it literally floats at 32 pounds and it had about 32 pounds of thrust, and he says it literally floats off the ground completely.
Really?
I mean, I have no. I got to be a little bit skeptical, but I mean, the guy worked.
Yeah.
At, the guy helped work with the. He had a top secret clearance, and he worked on the Saturn V rocket back in the 60s. I mean, he's a smart guy. I just don't see why he would lie. I mean, maybe he really has done it.
Yeah.
But
he's either waiting for a patent.
That's it.
I think he's kind of like, screw it. He's just going to just die with it. He's going to just never patent it. I think he says,
wonderful.
He says the government's going to probably come and take it anyway. So he's like, I'm just going to die with it. Never. So, I mean, I'm like me and a couple people are the only people that know about the other stuff. I mean, if he dies, I don't know. I mean, I don't know what I'm going to do then, but maybe my friends and me can patent it for his family, I guess. I don't know. I mean, we could do something like that. I don't know. I mean,
yeah. Well, guys, let me, if it's okay, let me jump in really quick. I want to, and thank you as well, Robert. I want to ask Phil Bouchard. Phil, you have a person who's going to present tonight.
Yeah.
Do you know if she is here or?
Yeah, I asked her to connect. I sent her the link. So did you get a request from a guest or something like that?
And that's fine. That's fine. I'm in no rush. I just wanted to make sure that we didn't keep.
I'm actually I'm there.
Okay.
Okay. Well, do you want to do that then before? So we can come back to Q&A stuff. So would you like to introduce yourself? And so this is kind of an open session question. Let me put the hands down if it's okay, because I'd asked you to come at 5 and I know that we're running over. So if it's okay with everybody, Mark, is it okay to transition over to her presentation?
Sure. How long is it?
I'm genuinely not sure. I think she had about 10 slides.
Yeah, I guess it's about an hour that Phil told me, but it depends of the question. It depends of what you want to know. It's very informal even for me. So it's
I mean, if it's an hour, let's just do John Brandenburg and Riccardo real fast.
Okay. Well, we'll do that then. So let me go to John then. John, go for it, sir.
John, you're muted.
John, you're still muted, sir.
Maybe you can ask him to unmute.
Yeah. John, can you unmute yourself? There he goes. There we go.
There, yeah, Mark, good to see you again after your visit to Kepler Aerospace the other day.
Oh, yes.
It was so nice to see you, and I think, yeah, your female companion. And I just wanted to comment that it would be kind of more effective in your demonstration if you did let it go so it could fly off the table. But of course, I don't want you to damage this thing. But this reminds me of in Hitchhiker's Guide, they said always carry a towel, perhaps made of cotton.
I was counting on his sleeves
Yes.
to shut it down.
Sturdy sleeves.
Yeah, we've had to do that before to arrest the gyros. They're spinning at like 10 to 15,000 RPM, and they weigh a little bit more than 1.5 pounds of brass. Spinning at 15,000 RPM has a lot of kinetic energy. If this thing were to hit the table, not only would it damage all that, it would gouge the table too.
Oh, okay. Very good. You've answered
Okay.
my questions.
Thank you, John. Okay, and let me go to Ricardo now, sir.
Yeah, look, just something I just wanted to mention. There was talk before about patents. Now, if anybody has an issue with patent, or getting one out because you fear of it being stolen by a government, patents are country specific. So when you take out a US patent, for example, it's not a global thing. It only works in the United States. So I went to Mexico, for example, and you took out the same patent there, then it's protected in Mexico, and not even the US government can take it away from you because it's a different legal system, right? So different jurisdiction. So that's how they work. And companies like Microsoft, for example, literally have the money to be able to take out a patent, software patent or whatever it is, in every country around the world. In the case of Europe, you can take out a patent, say, in Italy, but that's recognised by the European Union, so you kind of protect patents are country specific. It does come with consequences, but yeah, I just wanted to make that point. That's all.
Wonderful.
That's it.
Okay, well, thank you.